Hello, officially welcome to the 9th of the Rescale Solutions live webinar series featuring hands-on demonstrations of the top science and engineering applications on Rescale. My name is Jolie Hales and I will be your moderator today. I'm with Rescale as well, as you can tell by my Rescale shirt here. Today's focus is on performing operational weather forecasting on Rescale. We also wanted to make you aware that we do have a number of recorded webinars from this series, as well as other how-to videos and presentations and information that's available on the YouTube channel for Rescale. So you can feel free to go ahead and check those out. All right, without further ado, let's go ahead and get started. So we do have one presenter lined up for today. Chris Ramirez is a solutions architect at Rescale. Chris has a master's degree in physics and years of experience in computational physics and high performance computing. He's programmed applications to simulate the early universe, which is pretty rad, and he's also architected, deployed, and managed on-premise HPC clusters for university and enterprise customers. So at this time, Chris, I will go ahead and hand over control to you.
Awesome. Thank you, Jolie.
Sure thing. Take it away.
Go ahead and get my screen shared with you all. All right. So hello. Like Jolie said, my name is Chris, and I have done a whole lot of work in the HPC field. Lately, though, it seems like I've had to put a lot of focus into this whole weather forecasting bit, but it's okay because I have a pretty vested interest in this. I'm actually from Houston, so if you've been caught up with the weather at all recently, there's been a whole lot of hurricanes and storms coming my way. So it's in my best interest to make sure that this stuff is running really, really well now. So we'll go ahead and get started. Like I said, we'll be discussing operational weather forecasting on Rescale. And so, I'm going to go ahead and go into, so I know not everybody is probably going to be a meteorologist or somebody that does this as an everyday job. So I'll do a brief overview of what numerical weather prediction is, a little bit of information on operational weather forecasting, and then I'll really go into what we've encountered as Rescale, and what we've done to enable this, to enable operational weather forecasting specifically in the cloud. So to start with, when we look at something like numerical weather prediction, what you're really looking at is just a whole bunch of math equations, which I'm sure if anybody on here is familiar with any kind of HPC work, it's the same across the board, right? And so you're using all these math equations to really try to predict what the weather is going to look like. There's a lot more that goes into this. So there's a few subsets of the types of numerical weather prediction that you can do. So there's climate research, so climatology. You can do fire modeling. There's energy companies, and especially the DOE, that are doing wind farm parameterizations. You have groups like the USGS that do coastal change studies. So whenever there's a storm that comes in, they need to see what the sediment transport looks like coming off of the shores. And then, of course, the big one, right, is operational weather forecasting. So this tends to be the most important. I won't say the most important because I don't want to offend anybody on the call, right? But it's the one that gets, I guess, a lot more visibility because you see it every day on the news. So to go into operational weather forecasting a bit more, right? So it's really just the prediction of atmospheric conditions, or what the weather looks like for a specific area at a certain time. All right, so this is the kind of stuff that you would see on the news, giving you hurricane tracks. Like in this case, this is an ensemble forecast of Hurricane Sandy. So seeing the different tracks of the different possible paths that a storm may take as it goes through here. Right, so the reasons that, I guess one of the biggest reasons that you would look at for operational weather forecasting is for the protection of life and property. So I made mention of some fire spreading, or being able to simulate how the interaction between the airs and the ground fuels and the atmospheric conditions to determine what the spreading of the fire looks like. So there's versions of software of some of the weather models that they can go in and predict how these fires are going to burn, right? So stuff like this specific example in this image that you're seeing is actually a controlled burn that helps prevent wildfires like what we're seeing in California and other parts of the state of the United States right now. So they can go in and predict how these controlled burns are going to spread to prevent them from getting larger, or at the same time they can go in and use the same kind of simulations tool to predict how wildfires are going to spread in general once they've started off. So when we talk about this, you also want to consider, well, who's doing this, right? The base assumption for a lot of people is, oh, it's the government, it's NOAA. They're going out, they're predicting the weather, they're feeding this to all the news organizations, and that's partially true. What we really see, and what we've seen at Rescale, and just kind of in not just at Rescale, but in other places as well, just kind of stuff out in the wild, is you have a lot of commercial applications of people trying to use a lot of operational weather forecasting for things to consider. And one of the big ones that I personally never considered was probably these insurance companies, right? So they'll do a lot of catastrophe simulations. So they'll go in and they'll do these simulations using stuff like WARF or FE3 or whatever modeling tool that they're trying to use. And what they're trying to do is predict, assess, the amount of damage that's going to occur in an area to kind of determine, well, do they need to send people in? What's kind of predict what kind of costs they're going to incur, as cynical as it sounds, from these storms. And then of course you have these other organizations, right? So you have people like AccuWeather and the Weather Channel that aren't necessarily associated with the government entities that we're used to seeing, that are still going out and producing weather forecasts for different customers. The Weather Channel is its own thing, and they do their own simulations. It's the same thing with AccuWeather. And so they generate these products and they push them out. And then on the other hand, right, we have these government perspectives. So when we look at the government, you have groups like NCAR and UCAR. You have NOAA, the Department of Energy, the Department of Defense, USGS, the Department of Interior, a whole bunch of different organizations that are going in and they're doing operational weather forecasting. And they're running these simulations to help them sort of determine what the weather is going to look like, or what, depending on the needs of the customer that's consuming their reports. So all that being said, we can kind of go into now what Rescale is seeing, kind of where interest has been generated as far as what, using Rescale in the cloud goes, or I'm sorry, using weather in the cloud, because Rescale lives in the cloud, right? Weather predictions and weather forecasting in the cloud, and kind of where there's a lot of interest coming for this, right? So we've seen examples of the Naval Research Lab starting to do work with AWS and other cloud providers to start running their NavGem model and do some work there. NOAA, we've seen NOAA doing some work with FE3 as well, and UFS to kind of go in and do a whole bunch of work trying to see what value the cloud can bring to these weather predictions and this weather modeling that they're doing. Same thing with NASA Ames. They're using stuff like Planet WARF to start doing predictions of what planetary climates are going to look like and see weather on Mars. And it's kind of essential for what they're doing is when they're landing these rovers and stuff. And then of course there's a whole bunch of private sector organizations that are out there, and they're already doing a whole lot of this stuff in the cloud. One of the biggest things that we've seen is wind farm parameterization. So there's organizations that are coming in and they're doing their simulations using stuff like WARF to simulate how wind farms are going to affect the climate, so the temperature above and below the actual wind turbines. And actually there's a couple of private sector companies as well that are doing a lot of fire simulations to see how the fire interacts with the climate and the atmosphere and the ground fuels and kind of determine how these things are going to spread. So we see a lot of that. We've seen a lot of that recently coming in, and we've seen interest there. So when we take all these things where people are looking at it, there are some organizations that have already started working in the cloud, and I think the one that pops to mind for Rescale especially is NCAR and their AMPS team. So NCAR's come in and they're actually our first production weather company that's come in and produced an actual product using Rescale. I'll get a little bit more into that later. And then we have some other private sector organizations doing the same thing. And so when you look at the cloud and you look at everything that the cloud is starting to offer, there's a lot of potential that we can address by making this sort of a move. So you're starting to look into big data access. Now you're getting you'll have access to the resources you need to start poking more with AI and ML and integrating that into your workflows. It also allows for a lot more collaboration, not just within your organization, but with other teams, globally or across the country. And there's also the idea that there may be a better way to run some of these forecasts. Not just to go in and have a simulation that finishes super quick and get all this stuff done, but maybe another way to make it more redundant so that you're always on time with the final product that you're trying to generate. So looking at all of this, right, I'm going to start getting into a little bit more detail about how we do how weather simulations are done and some of the requirements. So I'll start building on this as I go through these next few slides. So one of the big things that we see, especially with operational weather, is that you have to have data, right? And so a lot of these simulations are done on new data that's fresh from a satellite or from a radar that comes in, and they need to generate these simulations in a very timely fashion. So you have this path, right? This data path that all this raw data takes when it first comes in from these satellites or these radars, whichever it is, whichever data they're deciding to use, and it moves in. And it takes this movement into something like INCEP, which is pretty much a data repository if you're not familiar with it. And so INCEP will come in and they'll take this raw data and they'll make it into a consumable form for the customer, right? And the customer being the people that are actually doing these forecasts. So groups like NCAR and NOAA, they're pulling this data in every time they need to kick off one of these runs every morning to make sure that somebody has the correct forecast for the day. So when you're pulling in this data, it has to go somewhere. And so now I'm going to get a little bit more into the details here, right? So when you're looking at these workflows being done in a high performance computing environment, you're taking this initial data from INCEP, and then it's being pushed into a cluster storage, right? So some kind of shared file system within your cluster that needs to be accessible from all your compute members. So what you see here is just a couple of different ways that these simulations are run, right? So you have an individual one-off run, kind of similar to what AMPS does. And then you have these other runs that are called ensemble forecasts, where there's multiple members doing a simulation that are all feeding off of the same initial data, and these are all running at the same time. So if you want to, for those of you that may not be familiar with this is how generally when they do these storm tracks, when they start generating the little spaghetti models that you may see where there's a whole bunch of different tracks for a hurricane to take, this is one of the methods that they use to generate those different tracks to really get an understanding for the behavior of the storm. So let's keep this in mind, and as I get a little bit deeper into this, this will play an even bigger part. So when we look at this, though, there's a couple of different groups that have done this with us that we've helped enable these kinds of workflows. Like I mentioned earlier, the first one is NCAR or UCAR and the AMPS team. So they've come in and they do a whole bunch of predictions. And so the binding story with this is that the workflow is extremely complicated, and it's not just, and this isn't just specific to UCAR and NCAR. It's to a lot of these other other people that are running with these weather forecasts as well. So we've done some sample runs with NOAA, and there's an inherent complexity to the weather codes, right? And there's a lot of stuff that needs to be done in the background to make sure that they run well and that they're optimized. And so this was the experience that we had with UCAR and taking their versions of WRF and trying to set things up so that they can run this consistently and repeatably when they needed to. And then going into the next group, right? So we work with NISL, or the NOAA Severe Storms Lab up in Oklahoma. And the idea was the same, was that they kind of had this idea that they have very complicated code, but for them it was more about running this code in a better, with a higher resolution, and being able to use this across more pieces of software, because they have a system there, but it's not always large enough for their purposes, right? So one of the things that we did with NISL was we took them and we helped them to set up their workflows on Rescale so that they could really start to scale out to larger sizes. And so to give you an idea of what this looks like, so if you're a weather person, I'm sorry for a lot of the, the stuff that you already know, but one of the things to consider is that when you're looking at weather predictions, as you increase the resolution or the size of the grid for each of these runs, there's a very large increase in how much processing power it takes. So if you just look at this first one, these first two cases in this image, you have these two models where you have this 12-kilometer grid and a 2.5-kilometer grid. And so just jumping from 12 kilometers to 2.5 kilometers, you can see this number of grid points per core, or total grid points, sorry, scales up unbelievably huge. And so you're not only is this scaling up very large, but you're also increasing the amount of runtime. So if you want to decrease that runtime and you want to stay within this time constraint that usually comes with operational forecasting, you have to really increase the number of cores that you're running with. So you need to run on a larger and larger system, the better that you want to try to predict this stuff, because just like in all simulation, right? No matter how you set up your job or how you run this, there's always going to be some kind of approximation that comes in that's going to really cut down the accuracy of the results. So the larger, the better your resolution, the better you can run this with. And so that's something that we worked with NISL on to enable them to run at a finer resolution. There's a couple of other little things that we did with them as well, but I'll bring that in towards the end. So really, this is where Rescale has been putting a lot of focus with meteorologists and the weather forecasting groups to try to really determine how we can enable these workflows to not just run at parity with what you have on premise, but to take that and also expand it and allow you to do a lot more with what you have available to you. So this takes me into what is Rescale doing, right? So what are we doing to help these people? What are we doing to help these weather folks do these predictions right? So let me start at the high level of what Rescale is, right? So Rescale is a platform. We're an HPC platform. We take all this software, we install it, we optimize it, and we set it up for every single piece of hardware that we can imagine that you may need to use for it. And so we'll make sure that you have the right hardware every time. We take all of this and we integrate it with a full HPC stack. So job orchestration, pulling in the right libraries and dependencies, making sure everything's in place for you to really just come in and click, do a couple of clicks and kick off a run. And then we make this available to you, not just on a defined set of hardware. So you're not just stuck with either AWS or Azure or Google Cloud. Because of the nature of Rescale, we enable you to access every single cloud that we've connected with. So AWS, Azure, and Google Cloud. And then on top of that, there's the ability to connect to your on-premise cluster. So if you need to do some kind of research work, you can do the development piece on your cluster, and then burst it up and then bring it back up into Rescale, and we can send it out to any and all of the cloud providers to run. And I'll get into this a little bit more as well. So like I mentioned though, right, we take all of this and the big piece here is that we take every single element that you have of HPC, so your applications, the licensing, the support, your hardware optimizations, the infrastructure, anything that really traditionally falls into this HPC build, or the process of building this cluster or orchestrating these jobs in a traditional HPC environment, and we wrap them up into one place. And then we take that and we make it available across all these different cloud providers and give you a whole bunch of different options as far as accessing your hardware, and to really enable you to be as prescriptive as you need to be with your runs, because not everybody needs the fastest core type on earth to run a job. Not everybody needs, a 300 gigabit InfiniBand connection. So there's really a lot of granularity in selecting the hardware that you need to do the run that you need to run. And then the last piece, right, is that Rescale also connects to, because we can access multiple clouds, we can connect you to multiple platforms or multiple places globally. So just within the US, you can log into Rescale, you can run a job on the East Coast, you can run a job on the West Coast, and then you can move into the next cloud provider and you can run jobs across all of their data centers as well. And this is all accessible to you from the exact same interface with no extra work to you. There's no extra integration piece. There's no extra tools that you need to run in the background to do this, right? And so the idea is that we can do, by doing this, is that I guess the way to say this is the way that we tie this back into weather forecasting is that now if you happen to be running in a particular region, especially if you're on this time constraint, right? And for whatever reason, that lightning strikes the data center and the data center goes down, you're not constrained to just running in this one data center. Rescale will automatically orchestrate your job to get submitted to a new region and kick off that job in that region, and you don't have to worry about making that change because we'll do it automatically for you. So let's get into the nitty-gritty now. So I'm going to show, this is a reference workflow, and I'm going to kind of use this to speak to the next few slides. And so the idea is that when we look at a typical weather workflow, even if you look at it on premise, the general idea is the same. You have a user that's going to kick off a job. They're going to kick off their job, and the job is going to pull data in from INCEP, and then it's going to do the compute time, or it's going to do the simulation, and then the data is going to get pushed back. So to be a little bit more specific to Rescale, what we're actually doing is the user is submitting a job to the Rescale platform. They're not uploading any of their file. The only file they're actually going to have to upload is if they're using a job script, or if they're using a script to drive the simulation for them because they may be doing some post-processing or they have to massage the data a certain way. They would upload that initial script, and then they would kick off a job. So this job would come in, it would provision the hardware here, and then as the hardware is finishing its provisioning process, we start pulling in this data directly from INCEP. And so instead of having to wait for the data to be pulled from INCEP into your cluster, we're pulling it directly into the job that's running. So the benefit of this is that if you need some kind of high availability or you need some sort of redundancy, you can actually kick off this job twice, and it's going to pull the data into each of those jobs. So you're not having to worry about if your shared storage device happens to die on you and the data is already there. Each of these jobs is going to have it already ready for them. The next one, the other example here is this ensemble forecast. So the big difference here is that you see this shared persistent storage device. So all we're doing in this particular workflow is we're taking data from INCEP and we're putting it into a shared storage device so that each member of the ensemble can kick off and pull the data from the same place. So this comes into play for a few reasons, right? So let's look at the first scenario that we have as far as executing weather predictions in the cloud. So the first scenario is fairly straightforward. User logs into Rescale, they kick off a job, and the job goes directly to a single cloud provider, and it runs with a single hardware type or in a single availability zone. This is a good representation of actually what we did with the AMPS team. So the AMPS team came in, when they kick off a job, they usually start this up. They'll submit their driver script and they'll put in their input parameters. So Rescale will come in, will verify the job, and as the job is completed with its verification and we do the hardware verifications, we start pulling in the INCEP data. Once the INCEP data is pulled in, then we kick off WRF. And so as WRF runs, it goes and it does a prediction, and then it gives them their final output product, right? And so in this case, the final product for them is this weather forecast. And so a little bit of trivia here. This is actually the first image that was done on Rescale for production weather. We were very proud of it, and the company as a whole was very excited when we got this image back from the AMPS team. So if you guys are out there, thank you again. So it's a fairly straightforward workflow, and it's very easy to duplicate as many times as you need to when you need to do it, because like I said, Rescale takes care of all the orchestration and making this as straightforward as possible. So the next scenario, right, is let's say now we have a little bit of redundancy that's required for our job. Or maybe it's not just redundancy, but maybe we just need multiple types of hardware. So we can have a user come in, they can kick off a job using the exact same platform, the exact same process, but now the only real difference is that they're selecting a different piece of hardware. So when they select that piece of hardware, it'll kick off in whatever region that hardware is available. So you can see here, they can run on either hardware in region A, or they can go to region B, depending on what the status looks like, or what their preference is, which we can help you guys determine when you decide to run this stuff. And this enables you to do either redundant runs on both sides. So if you have a product that you need to have out by a certain time, you can kick this off in multiple regions, and you can be assured that at least one of them will complete. So you're not having to stress over, well, if the main cluster goes out, then I'm going to have to restart this job, and now my product's going to be late. You can do this concurrently, and it'll be done at pretty much the same time, and you'll have the product that you need when you need it. So then the last scenario that we like to look at, and this is probably the more interesting one, because this also opens up a lot of doors to other possibilities. And so this one is concurrent execution in separate clouds. So the idea is that now you're not just relying on one cloud provider, right? You're spreading your stuff out in as many places as possible, so that you can make sure that you're going to have the run completed when you need to. The added benefit to this also, though, is that there's a lot more hardware available between the two of these different providers versus just using a single provider and only having, you know, like, let's say if you needed an InfiniBand connection or a high interconnect available to your job, which if you're here, it's more, I'm like 90% sure that you're going to need something like InfiniBand at the very least, right? So the idea is that now you can take this and you can run this in one cloud provider, because you know they have the InfiniBand connection that you need. You know, let's say you need a 300 gigabit InfiniBand connection, because why not? You want to run on 300 gigabits because it's pretty new, right? Well, you can do it in Azure, but then you need to do some other runs that kind of cut the cost a little bit, right? So maybe there's something that's a little bit cheaper in AWS, and you can use that one and you can run it there as well. And there's really no difference there's no additional work for you to set this up, because it's already done for you. And so when I say that this is the more interesting scenario, right? So if you were at AMS this past year, you may have noticed that there was a very large, I don't want to say a large presence, but there was a buzzword that was going around, and I think the buzzword was exascale. Right, so I am in no way saying that Rescale can do exascale computing right now. But the idea that you can run across multiple cloud providers in multiple regions really lends to the ability of saying that, you know, there is a possibility that if there is a true exascale application that needs to be run, this may be a good approach to doing it. And so in looking at this, we can take this and extrapolate forward and say, you know, well, maybe in X amount of years, this is something that we can tie together really well and have a true exascale application running at true exascale speeds with a click of a button, right? So anyway, I was going off on a little tangent there. It's just because I have a lot of interest in exascale. I'm really curious as to how that problem is going to get solved. So anyway, these are probably the three biggest scenarios that we've seen so far. And these are just basic ideas of how we implement these. A really good example for this last one is actually kind of what we did with NISL. And so with NISL, their job they wanted to run at a higher resolution, and they didn't have the resources available to them right away. So when they came to us, we helped them to run, inside of these cloud providers. One of the things that we helped them do, in addition to running across multiple cloud providers, was to containerize their instances of WRF. And so by containerizing them, they were able to build the application once on their main system. They took that same container, and instead of waiting for us to help them do the install and kind of go through the whole optimization process, we got the process nailed down. And so we built a container, and then this container was portable between their system, between all our cloud providers as well, and we were able to kick off runs and make sure that it was running correctly, and they were still getting pretty close results. Because of course there's a little bit of variance, but the initial feedback from that exercise is actually fairly strong. So if you want containers, I can help you. So that's about it when we look at this, right? So here, if you're looking at this and you're asking yourself some questions, right? So uh, especially if you're somebody that administers the cluster, you're somebody that's extremely involved in the development of the software. There's more questions that come out of this, right? So what about file systems or compilers or libraries? What about these scripts that I'm using or visualization or, as I mentioned, containers, right? How does all this stuff fit in? Well, with complicated workflows like this, there's a lot of places for things to go wrong. So there's a whole lot of characteristics that come into the HPC world, especially when you're trying to design this cluster and you're trying to create this process that's repeatable, that gets you repeatable results. And so with Rescale, we do our best to handle a lot of these concerns for the environments that you may see. There's a few things that are kind of unique to us, right? Because of the nature of what we do, and that we are cloud agnostic, but also now we can do this hybrid model as well, where we're running on your clusters is also. And so there's a lot of questions that come out of it, right? And so a lot of this, when we look at this infrastructure piece, is that the biggest things that we learned, at least, was that your hardware choice is really, really important, right? That's a given no matter what you're running on. So a lot of your weather codes are going to need to run with an InfiniBand connection or some kind of high-speed interconnect. And at some point, not all the cloud providers had these high-speed interconnects, at least not in a usable form for operational weather. And so having the option to go between multiple cloud providers is what made it a lot easier to come into Rescale and do the work that needed to be done, because somebody had stuff that was available that the other ones didn't. And so even if they do have similar hardware, it's not always exactly the same. So there's maybe a generation behind in their fastest processor, or there's just something that's a little bit different. So there's a lot of things that Rescale helps you to figure out, and to make the best choices to run your software and get it to where it needs to be run for your purposes and up to your standards, I guess is the better way to say this. There's MPI issues, because it's the nature of the beast is that everything that we run is going to be tied into MPI somehow. Some of the cloud providers ship their own versions of MPI because they can. And sometimes if you're not aware that it's there, it's going to cause a lot of issues. This is something we ran into when we were trying to run with a FV3 and using UPP on on Azure. This was a big issue that we saw with this package version of MPI that they had. The other piece, right, and this is a really fun one, is it's getting the code to actually work in the cloud. When you're compiling code yourself, it's not easy. I'm sure everybody on here knows that. But working in a cloud environment where we're trying to create this code that can go between different types of hardware and run well, especially with different cloud providers, and they all have different architectures, it becomes an even bigger project. So we're trying to find ways to get around the traditional means of optimizing the software and get it to the speeds that you're used to seeing with your on-premise systems, and something that we actually do pretty well now. Just tooting our own horn. But it is a big project, and it's not a straightforward piece. If you can ask any of the people that we've worked with and reach out to them, and I'm sure they'll tell you that there was a whole lot of cooperation that had to go on between us to make sure that the code was running, at 100% most of the time. So, this other lesson, right, is also that even if you're running in the same cloud, things aren't always the same. It's just the nature of the cloud. You have different data centers and different availability zones, so stuff has to be moved around, and we orchestrate that as best as we can. Another thing to look at is just kind of what happens with the workflows. So those of you that are familiar with WRF know that one of the biggest problems that WRF has is there's a lot of really old code in there. And I'm not exaggerating with that many reallys. There was a few pieces we found that were pretty archaic. And so a lot of those can cause a lot of issues, right? So version control of the libraries and the dependencies and the compilers is extremely important for this kind of stuff. And so it's one of the biggest things that we saw that was that caused a few issues. So we had to play with a lot of different versions of software or of compilers and libraries to make everything work correctly. But I think the other thing too, right, is this time to move the data. So when we're pulling data directly into the instance from INCEP, it really slows down the amount of time that it takes for us to provision a system. And so you're going to see you'll see a quicker turnaround, because now the only real bottleneck that you have as far as connection is going to be between the cloud provider and somebody like INCEP, versus where if you're sitting behind, if you're sitting on your home system and you're behind like 4 VPNs, and one of them's Cisco, one of them's a Palo Alto, and they're just conflicting with each other, and you're trying to get data into your system, but just it's just going unbelievably slow. All of that's removed here. So you're going to get a better data migration, at least into the instance, and then there's ways to move the data afterwards. So all that being said, this is something that we've put a lot of time into, and it's something that we're very, very invested in here at Rescale, is making weather work in the cloud for you. So with all that being said, let's just real quick, in summary, this is Rescale at a glance. Like I said, we are an HPC platform. We're based in the cloud. We work with multiple cloud providers. We work across different geographies. We also integrate with your on-premise system, so we can provide for hybrid infrastructure for you to run not just your on-premise systems, but also your any of the cloud providers that you may be running with. We offer you a full stack from top to bottom, from hardware all the way up to your application layer. Everything is managed for you, and we really do our best to try to simplify everything. And of course, there's all this compliance piece and everything that we also tie into as well. So if you have any questions about that, we can definitely answer those. And all that being said, I will open this up for questions. But before I do, I just want to make sure that I really thank the two Kevins. They know who they are, and I could not have put a lot of this together without you all, and I don't think we would have been as successful in this weather front without you two and the teams that have supported you guys. So questions, please.
All right, awesome. Thank you so much, Chris. I love that, thanking the two Kevins. I feel like I want to meet these two Kevins just based off of that. We do have some questions that have been coming in, and if anybody out there does have other ones, feel free to type those in the question window there for the GoToWebinar platform. So the first question is from, and I may say your name wrong, I apologize profusely, Anil, and Anil asks, are you using Python programming language for model configure, scripting and execution, post-processing, and visualization?
Yes, we do have some people that have started to integrate with Python a little bit. As far as Rescale goes, we haven't done a full integration with it, but yeah, it's something that we definitely do support, and it's something that we have a little bit of experience with.
Great, and there's a follow-up. Do I need to install WRF on cloud, or will you provide WRF in all of that environment?
Yeah, so there's a couple of different ways that we do this. Really, if we're looking at this, we'll call it the operational or the production versions of your code, that's something that will actually work with you to install and set up so that you don't have to install it. That being said, if you're on a more let's say research and development focused team, it's actually something that we can enable you to do, to go in and do the installations yourself. So if you're on a team that constantly updates the code, every other week or every other month, that's something that we can enable you to do as well.
Great. Another follow-up, and also help on developing workflow?
Yes. Yeah, we will definitely help you on developing workflow. I understand it's not straightforward, especially in a new environment, and it's something that we definitely do. Just as an example, let me pull up this other screen real quick. Let's see. So we did a similar exercise with this FE3 workflow. And so as you can see here, it was not a straightforward workflow at all. And so we helped them to really come in, and this is kind of this was eventually all placed in a script that could just be repeatedly run, but this was a lot of the setup work that we did with them to run this FE3 model. And we did the same thing with UCAR as well, where we helped them really to work through their workflow and make sure all the pieces were in place so that they could do it repeatedly and very easily as well.
Yeah, great. Yeah, thanks, Chris. Another question popped in here. This one's from Josh. Since most weather models conduct a lot of I/O and need a parallel file system, how do you address that need?
Yeah, so that was a tricky one, right? So AWS, if you're aware, AWS has their own solution for parallel file systems, right? And it's called FSX with Lustre. Azure, on the other hand, doesn't have a defined product yet, but they have the ability to implement it. So trying to remain at this cloud agnostic level, what we did versus using a hard implementation like that was we actually used BGFS to one, cut down the cost, right? So you're not paying for this additional file system that you need to spin up and leave it sitting there running for scratch space. But two, you're also taking BGFS and it's taking the available storage across all the compute nodes and it's combining them into one parallel file system. And so our initial results, even without optimize, like we didn't even optimize BGFS the first few times we ran this, but our initial results were actually really, really promising, and it scales extremely well in this kind of an environment. So the more nodes you add to it, the better the IOPS scale with it. And so it actually turned out to be a fairly powerful solution for something like a parallel file system in the cloud. And it also makes it easier for us to support it across multiple cloud providers and hardwares.
Great. And another question from someone with a name I can't pronounce. Mosim asks, hi, what happens to the WRF output files in NCAR, so NCAR or NSSL workflows? Do they remain in cloud storage or are they transferred to local or some of their archives?
Yeah, so it really depends on what their preference is. Generally, what happens is once all the data is done being run on Rescale, we'll move it back into what we call Rescale Cloud Storage. And so we maintain that data for them. And then whenever they feel like moving it down to their own systems or moving it into archive, they can. The other option, of course, is to do it straight from the instances as the job is running. So as soon as the job is running, we can help set up a transfer mechanism to transfer that data directly into your archive, wherever it may be.
Great. Well, it doesn't look like we have any other questions here unless I see one pop up before we officially end. But I think we can come to the conclusion of this presentation. Thank you so much, Chris. This has been extremely enlightening, at least for me. I know little about weather forecasting. I know so much more. And all of you who have joined us, thank you so much for being here. Just a reminder that you can find helpful Rescale hints and information on any of our social channels, including YouTube, where we often post webinar recordings and other interesting videos. And I do plan to get this video up by tomorrow as well if you want to reference it in the future or share it with somebody who might find it interesting. So thank you all again and have a great day.
Thanks, everyone. Have a good one.